Hello everybody, welcome to my channel again. Today we want to discuss on how to run flood mapping on Google Earth Engine. We want to see how we want to analyze before the flood and after the flood. We are going to have data before the flood and after the flood. Then we can, at the end of the day, we can see what areas that are affected by flood at between these two periods, before the flood and after the flood. You can see areas that are affected by the flood. So without wasting our time, let's jump into it. I have the script somewhere here. I have flood mapping. Let's go into it. All right, so we have it now. We're using now our area of interest, AOI. We are considering Nigeria as our area of interest, and we are using the Sentinel 1 satellite imagery for flood mapping. This is the satellite imagery. We can check it out. Let's check it out. Okay. This is it. Sentinel 1 SAR GRD C-band synthetic aperture radar. Sentinel 1 SAR synthetic aperture radar ground range detection. That's the meaning of GRD, ground range detection. So let's look at it. So this is it. Now the description is said the Sentinel-1 mission provides data from dual polarization C-band synthetic aperture radar instrument. The collection includes the S1 ground range detection scene processed using the Sentinel-1 toolbox to generate a calibrated autocorrected product. This is, let's say, the bands. Now they say the single copolarization vertical transmit, vertical receive, HH single copolarization horizontal transmit, horizontal receive, 3 VV plus VH dual band cross polarization vertical transmit, horizontal receive. Now this is the data, and the data set is available from 2014 1003, that's October 3 2014, and this is the SNPnet. You can just copy like this, copy this and paste it on your Google Earth Engine interface, or you can import it to have it. Let's see the bands. We have the HH bands. There is it, minimum and maximum. We have the HV band, we have the VV band, we have the VH band, and we have the angle band. Now understand that the star here equals the value are estimates. So if you see a star somewhere, it indicates that the values are estimates. So we close. Now what we do now, the next thing is once we have our satellite imagery imported, then we call out our filter bounds. We want this data, this particular data is for the whole world, but we want it to filter it to our area of interest, which is the Nigeria administrative unit. Then this is the bounds we are using, the VH. We checked the bounds the other time. Select filter receiver polarization, and filter to VH, and we are using the VH band. So if you we said we looked at it from the bands VH, DS. This band is what we're using. Dual band cross polarization, vertical transmit, horizontal receive. It's 10 meters, resolution. The VH, that's what we're using. So if you once you import this satellite imagery, you must quote this band, that this is what you want to use when you want to see around the flood mapping close. So here we say filter instrument mode. That's filter instrument mode. That's high W. Filter list contains. That's which band you want to select. We select the band, so we are selecting the VH band. Now we want to here we say pre-flood and post-flood dates. Now VAR pre-flood, that's before flood. That means you know that you select a time before the flood starts, and here is a VAR post-flood, that's after the flood. So this time is before the flood, and this time is after the flood. Now we say this is the script. Sentinel filter date, Sentinel1 dot filter date. Now we say 2020 0301 and 2020 0331. That's between 1st of March and 31st of March 2020. We said this is the pre-flood date. That means there was no flood within this month. That's 1st of March to 31st of March 2020. There was no flood, which is known. It should be a known date by you. You are the researcher. You should know the date that of the pre-flood date. Now the post-flood date. Now where we say for your specific area, for your area of interest, you may not be interested in the whole Nigeria as a whole when you are doing your map, but for your area of interest where you want to find out you want to run the flood mapping analysis, then you have to know the date, the pre-flood date and the post-flood date. Now here we say the post-flood date is we are considering 1st of April 2020 and 30th of April 2020. So we are looking at between April 1st of April to 31st of 1st of March to 31st of March and 1st of April to 31st of April. So we said these are the post-flood dates. You can alternate the date. You can change the date. You can put any date that is good, that you feel is good for you. You can put it. Now, what we are doing is we are taking this satellite imagery for these dates. For the false date, the median, we are taking the median satellite imagery between of Sentinel-1 data set of this band, VH band. We are taking it, the satellite imagery from 2020 0301 to 2020 0331. We are taking a median satellite imagery between these dates of this band. A Sentinel-1 satellite imagery, a Sentinel-1 satellite imagery with synthetic aperture radar, ground range detected, with this band. With this band VH, which I showed you the other time, from the bands, from the characteristics of this satellite imagery. When you go to the bands, you see the band that is that is the VH band. Now, here the same satellite imagery of this month, we find a median of this band. So these are the pre-flood dates and the post-flood dates. The date we are referring to here is is determined, is represented by a satellite imagery that is within this date range that is defined here, with considering this band. And same goes for the post-flood date. We are looking at the satellite imagery, that's the Sentinel-1 synthetic aperture radar, GRD, of this band within this date range in the median band. That's what we're looking at. Then here we say ensure image have valid data. That means the image must have a valid data. There are sometimes you don't have a valid data for the images. Now, to ensure that image have valid data, you are going to use pre-flood valid equals to that pre-flood validation equals to pre-flood dot band name, open band names, open this dot size dot gt bracket. Now, post flood date, we have post flood validation equals to post flood dot band names, the same date dot gt. Now to compute flood map only if both images have data. That's compute flood map. Now, if you run this analysis, if you have any image that shows, that means the two images have data for flood mapping. But if it shows blur or kind of whiteout, that means there is no data for flood mapping in the two selected imageries. So how to solve that? We will go and check for specific dates where there was flood and the specific dates when the flood were over. So, and you put the date here. So we say, okay, we are here. Now, compute flood only if both images have data. Now, and this is the function. VAR flood map equals the image algorithm if pre-flood valid dot and post-flood valid. That this is telling us is just executing this information. Compute flood if only both images have data. So this statement is represented by this. VR flood map equals the image. This is the image algorithm dot if pre-flood is valid, that's pre-flood has image, and post-flood also have image. Then it says post-flood dot subtract pre-flood, so that you want to see the flood map. So post-flood, after flood minus before flood. After flood minus before flood. Then it will help you to see the impact or areas that are affected by flood and areas that are not affected by flood. Because what we are doing here is, first of all, you define this, that run the flood map with these algorithms. This is the imagery, you call out the imagery, then run the algorithm if flood is valid, and if pre-flood is valid and post-flood is valid as well. Then say post-flood dot subtract pre-flood. That means post-flood minus pre-flood. Then to clip this imagery within your area of interest. That's your AOI. Then visualization parameters. That's the function is VAR vis params equals -1 to +1. And the palette is going to be from blue, white, to red. That's from blue to white to red. So, and this, at the end of the day, we're going to have, now we are say add flood map to layer. We want to add the what we describe, the flood map. We want to add it to the layer. We want to visualize it. We say map dot center objects. What are you mapping center object? Your AOI at level 12. Map dot add layer. Center object will only, like I said in my previous videos, center object will only make the screen, that's this screen, to pan to your area of interest, to focus on your area of interest once you run it. And then the map.add layer makes the map or the analysis to be visualizable for you to be able to see it. If you don't add layer, you won't see anything. You will just pan the map.center object will just pan the mapping interface, this interface, to your study area, but you won't see anything. But if you say map.add layer, then what are you adding? What layer are you adding? Flood map, which was described here. Flood map. If all these functions goes into flood map, now then you say map.add layer. You're adding your flood map, comma visparams. Your visparams your hue on the map. The blue, white, red, the coloration of your map, how your map comes out, so that it only comes out just with a single color. It comes in color layers, and you'll be able to differentiate areas from areas from the other. So, but the value will be from minimum -1 to maximum +1. Then here we can export our data. We can export it if you. So let's run it and see. Run. It's coming. Okay. Let's zoom out so that we see our study area. Okay, Nigeria. You see the entirety of our study area. Okay. Where is Nigeria here? Okay. You say it's coming. Okay, good. So you come to task, you have your flood map, which is there. So this is it, and let's go to, we have it, a flood map. Let's check some information out. It's a single band map. It's a single band map. That's why you have it one band, and it runs from -1 to +1. And the palette is blue, white, red. You have it blue, white, red. Now, looking at this, can close this. Looking at this map, this is the flood map of for Nigeria for this for the time period that we stated in the script above. Now you see different colors. If you see three different colors, the red areas, these red areas, you see the blue, and you see the white areas of the zone. You see the red areas, the blue areas, and the white areas. The white areas, the red areas, and the white areas. Now, the interpretation of this shows that the red areas shows the positive changes. Red areas shows positive changes. That means there are possibly dry lands. That means there are dry lands. The white areas shows no significant changes. That means they are unlikely affected by flood. They are unlikely affected by, because there is no changes. They still remain the same before the at the date of the flood, before the pre-flood, and the date after flood. They remain the same. Nothing changes. So they are not affected. They are unlikely affected by flood. While the blue areas represent negative values, where the backscatter has decreased. The backscatter of the flood has decreased in the blue areas. So these areas indicate potential flooded areas. They indicate potential flooded areas. So with the map, you were able to see areas that shows positive changes, which are regarded as dry areas, dry lands. We show areas that show no significant changes, which are the white areas. There is no significant changes, so that means they are likely unaffected by the flooding. And we have blue areas which represent negative values, which shows that they indicate potential flooded areas. So with this analysis, we're able to show those areas that are potential flooded areas, looking at the pre-flood time and the post-flood time, and then we're able to analyze and say, oh, these areas are potential flood areas. These areas, the blue areas, are potential flood areas. The red areas are representing they show positive changes, so they are possibly dry lands. They have shown positive changes, even looking at the pre-flood period and the post-flood period. They have shown positive changes, so they are dry lands. And the white areas show no significance changes, so they are not affected by the flooding. So with this, we end this our training on this section. So subscribe to our channel so that you can be informed on time on our new videos. Like our page, like our videos. And also, if you have any question, concerning this analysis, you can ask in the comment section. Thank you very much. God bless.